Welcome to Study Loop.
Welcome to problem number 23.64, chapter 23, electric potential. So we have a deflecting plates of an oscilloscope. So these are the vertical deflecting plates within an oscilloscope. So these plates are equivalent to parallel plate capacitor, or saying that the parallel plates but having opposite charge. So let's say this has Q charge and this has minus Q charge. The size of these plates is equal to 3 centimeter each. So that means this is a square in shape. The distance between those two plates is 5 millimeter, which is equals to 0.005 meter. So writing these sides are also in SI units, so we have 0.03 meter, and this one also 0.03 meter. So the first question is, we need to find out the how much charge is on the each plate. So we need to find out the Q here. The next question is, how strong is the electric field between the plates? So we need to find the electric field between them. The C part asks, if an electron is ejected from negative plate at rest, how fast is it moving when it reaches to positive plate? So we have an electron at this plate and it is being ejected. Or just they saying that the particle electron is released at this point on the surface of the minus Q plate. So we have electric field along this direction. Sorry, the electric field lines are along these directions. We have Q as negative electronic charge, which means that the force acting on the electron is towards positive Q. So let me make the diagram again. So we have plates as follows. This has plus Q, this has minus Q. The electric field lines are towards Q, which has negatively charged. So these are the electric field lines. We have an electron here at rest on minus Q sheet of charge or the plate. So the force acting on minus electronic charge, which is towards the positive. So the particle electron starts from here and accelerate towards positive Q plate, and it reaches some velocity at the finally at the position of the electron when it reaches to the surface of the plus Q. So we have Vi equals to 0 when it is at the place where minus Q is there. So Vf, let's say we have V and we have to find this value V. We have kinetic energy formula equals to half mv square, so we can use the conservation of energy formula to find out the value of the V. We know V is which is equals to potential here, which is Ed. So don't confuse, this is potential and this is velocity. So these two are different. And this U is our potential energy, which is QV. And the electric field between the parallel plates is sigma over epsilon naught. So sigma is equals to Q over A, which is surface charge density, Q is charge, and area is the area of the plate. So we will use this formula to find out the value of the all the parameters. So let's find out the value of the Q first. So we have V equals to Ed using this formula, which is equals to sigma over epsilon naught D. Sigma is our Q over A, so this becomes sigma. Put in the value of the sigma Q over A. So we have Q over A epsilon naught times D. Now the Q is equals to A sigma A epsilon naught, A epsilon naught V over D. We are given that the potential difference between these two plates is equals to 25 volt. So we have This potential V is equals to 25 volt. So we have A epsilon naught 25 volt over D. So D is the distance between the plates, which is 0.005 meter. Your area is side square, which is the square of the side, which is A square, which is 0.03 meter. So we have 0.03 square. D is your 0.005 meter. So we have 8.85 into 10 raised to the minus 12, which is the value of the epsilon naught. Now put in the value of the A square, this A square. Now put in the value of the here voltage, which is 25 volt. Now D, which is 0.005. So this gives us Q. Using calculator, so we have find out the value. This is 3.98 into 10 raised to power minus 11 coulomb, or is equals to 39.8 pico coulomb. 1 pico is equals to 10 raised to minus 12. So this is a charge on each plate. So this has positive charge and this has minus negative charge. So we have Q here. So let's find out the value of the E. E is sigma over epsilon naught, which is equals to Q over A epsilon naught. Or we can also find out by using potential. So we have V over D, which is 25 over 0.005. So this is equals to 5 into 10 raised to power 3 volt per meter. Now finding out the value of the velocity here. So we have Ki plus Uy equals to Kf equals to Uf. Our Ki is half mv initial square. The potential energy, let's say we put Uy here for a moment, and Kf is equals plus Uf. So 1 over, so this is equals to 0 because the particle is at rest at the beginning. So we have 0 square equals to Kf plus Uf minus Uy. So I have Kf equals to Uy minus Uf, which is equals to half mv f square, or equals to 1 mv square, equals to put in the value of the ui minus uf, which is equals to ed q. Now q is your electronic charge. So which is equals to EED. Now put in the value of the EE here, so which is 1.6 into 10 raised to minus 6 minus 19 coulomb into 5 into 10 raised to power 3 into D, which is 0.005. So after calculation, I have found out the value, which is equals to 2.96, which is equals to, sorry, let me check again with the calculator here. So this is equals to 4 times 10 raised to power minus 18 joule. So we have 4 into 10 raised to minus 18 joule is the energy. So I have half mv square equals to 4 into 10 raised to minus 18 joule. Now the mass of the electron is 9.1 into 10 raised to minus 31 kg. So putting this value, we have V equals to 4 into 10 raised to power minus 18 times 2 over m e. So this gives us equals to 2.96 into 10 raised to power 6 meter per second. So your velocity is equals to 2.96 into 10 raised to power 6 meter per second. So that's your answer for part C. You can take a look at it again. So we have first slide here, the second slide, and the third slide. Thank you very much for seeing.